Welcome back, Focus Learners. Today, we're taking a pretty massive leap in this explainer. We are moving away from those high-level conceptual AI designs and getting right down into the absolute nuts and bolts. We're going to talk about building a real production-ready AI routing layer. So, if you've been sitting there wondering how to actually operationalize your AI models so they run efficiently, reliably, and, without breaking the bank, well, you are in exactly the right place. Let's get to it.
Okay, let's dive into this. Are your AI routing rules currently hard-coded right into your application? Seriously, be honest with me here. Because if they are, you probably already know the sheer chaos of trying to juggle multiple different model SDKs, right? It's a nightmare. You've got Anthropic's SDK over here, DeepSeek's over there, and literally every single time a new model drops, it requires a full code rewrite and a totally nerve-wracking redeployment. It is a massive bottleneck. But good news, it absolutely doesn't have to be this way.
Over the next few minutes, we're going to demystify all of this. We'll cover the core concept, look at the anatomy of a router, reveal the configuration secret, talk about testing and observability, and finally, go over some common pitfalls and how your system can evolve.
All right, Section 1, the core concept. What exactly is an AI router? Simply put, an AI router is just a dispatcher with a unified client. Think of it like a really thin, highly controlled traffic cop. All it does is map an incoming task to a specific combination of an AI model and an access mode. And it does this based purely on explicit rules that you've written down. Then, it calls the target and returns the result, but crucially, it bundles that result with observability metadata so you know exactly what happened under the hood. It is not some overly complex, unmanageable black box. It's really just a lightweight dispatcher.
And this brilliantly illustrates a key point. Explicit, rule-based routing is what most production routers actually look like in 2026. A lot of teams make the massive mistake of overcomplicating things right out of the gate. They try building these elaborate machine learning routers when simple, pragmatic rules would have served them so much better. A rule-based approach, that is the genuine industry standard for building a reliable foundation.
Moving on to Section 2, Router Anatomy, the 5 components. Let's break this down.
Believe it or not, a complete production-scale router basically consists of just 5 little parts. First, you've got the task classifier, which evaluates your rules to decide the route. That's, maybe 20 to 60 lines of code? Next up, the route lookup maps that task type to a specific provider definition. Then, the client builder constructs the client. Fourth, the dispatch and call component actually fires off the API request. And finally, observability capture steps in to record the route, the cost, the latency, and the output. Honestly, if you add all that up, we are talking about maybe 150 to 200 lines of code in total. The complexity lives in your rules, you guys, not in the machinery of the router itself.
But here is the real secret sauce that makes this tiny anatomical structure practically viable: the unifier. Right now, the de facto standard is using one single OpenAI-compatible interface. By sticking to this single client shape, you completely bypass the need to import 5 different clunky SDKs. Whether you're routing a task to Anthropic, DeepSeek, Together, or even just firing up a local Llama instance, it's literally just one Python SDK and a couple of config variables. You optimize for this common path, and your codebase stays incredibly lean. It's a total game changer.
Let's hit Section 3, the configuration secret, treating routing rules as configuration.
So let's contrast the 2 paths you could take here. First, the bad path. Hard-coding your logic as endless if-else chains directly in your application code. I promise you, this calcifies incredibly fast. Every single time model prices shift or a capability gap closes, you have to completely redeploy your application to make a change. It's brutal. On the other hand, the good path is externalizing your rules into a configuration file like YAML or JSON. Your routes are defined purely as data. They're totally inspectable, and best of all, they can be reloaded at runtime without ever restarting your app. It's the ultimate organizational savior.
Now, what's really interesting here is why YAML specifically pulls ahead of JSON for these external files. Mechanically speaking, yeah, either one works. But routing rules are meant to be read and edited by human beings. YAML just gives you far better readability, it has way less noisy syntax for nested data, and, my personal favorite, it allows for first-class comments. You can use explicit notes fields to document exactly why you chose a specific model for a specific route, right there in the data.
Actually, if you take away only one thing about writing this configuration, let it be this: you must always, absolutely always include a default route. For example, setting up a catch-all like Claude Haiku 4.5 for general chat. If an incoming task just doesn't match any of your specific classification keywords, your router cannot just throw an error or silently fail. That is a disaster waiting to happen. The default route is your mandatory safety net. Don't skip it.
Okay, Section 4. Testing and observability, making the shift to operations. To know this is actually working, you need two distinct types of tests. First, you have your routing correctness tests. Think of these as your basic technical unit tests. They verify the classifier logic, run in sub-second times, and make zero actual model calls. They just make sure that your specific keywords trigger the correct rule. But then you also need end-to-end measurement tests. This is where you put your business strategy to the test. You run representative tasks through the actual models to capture the real-world cost and latency of each route.
So the crucial point is actually capturing the data to prove your efficiency. Imagine you're running a massive bulk classification task through a specialized, smaller model like Llama 4 Scout instead of some massive, expensive frontier model. The estimated cost for that single call drops down to roughly $0.00002. That is incredibly cheap, but you can only actually prove those savings if you've built per-call observability capture into your router from day one.
And here is where you really get to show the money. When you run those end-to-end measurement tests, you compare your router's total performance against a single model baseline. Like, imagine if you just sent every single prompt to Claude Sonnet 4.6. The measured, properly tested routing layer dramatically reduces your total costs. It proves mathematically that directing simpler tasks to cheaper models while saving those big frontier models for complex, customer-facing work is a highly, highly profitable architecture.
Finally, Section 5, Pitfalls in Evolution, How to Avoid Common Mistakes.
As developers, we have to talk about the failure modes. And there are 5 common pitfalls you need to actively avoid here. Number 1, writing rules that overfit to last week's data, which just causes silent misroutes today. Number 2, ever-growing rule lists that just become completely impossible to debug over time. 3, which we already talked about, is missing default routes that cause silent crashes. Number 4 is configuration drift, where your YAML config says one thing but some hard-coded environment variable in production is doing something completely different. And number 5, skipping per-route cost capture, which will absolutely lead to nasty surprises on your monthly cloud bill. Avoiding these just takes some strict, consistent operational discipline.
But look, even with absolutely perfect discipline, workloads are gonna evolve. Rule-based routing is an incredible starting point, but you have to know when it's time to graduate. If your rule list surpasses, say, 15 to 20 rules and they start conflicting with each other, or if your classification accuracy stalls out below 85%, pay attention. If new task types are popping up faster than your team can even write the YAML rules, or if disambiguating between tasks requires these ridiculously subtle keyword distinctions, well, those are your clear-cut signals. It is time to graduate from explicit rules to model-based routing, where you let a small, dedicated AI model handle all the classification for you.
Which brings us to the ultimate question you need to ask yourself as you analyze your own systems. Has your workload truly outgrown rule-based routing, or are you maybe just missing the discipline of a well-structured 200-line configuration-driven router? Master those rules first, capture your metrics meticulously, and let the real data tell you when it's time to evolve. Thank you so much for joining me in this explainer, and I will see you in the next one.